Howdy and welcome back. So this slide, or I guess this video is going to be quite short. We're just going to go over, I guess, the two different ways inheritance kind of works. And then in the next video, we're getting how we can structure an inheritance scheme in C++ and some of the different modes of inheritance that we will have available to us. So inheritance. As we implement these representations using inheritance in C++, so those of our truck, this idea of a generic truck, specialized trucks such as fire trucks, concrete trucks, and whatever sort of truck you fancy, two fundamental but related functions of inheritance should become apparent to you. The first is going to be implementation inheritance. When we define a derived type, such as a fire truck and its member functions, we can take advantage of the facilities, that is the data and member functions afforded to us by the base type. So if we created a fire truck, let's just call it FT. Since the base implements the forward behavior for us, we could write something like ft.forward. Likewise, we could store all that commonality, all those kind of truck specific aspects, the generic attributes of our fire truck within the base class. Now, interface inheritance is interesting, and the example I just showed kind of, I don't know, blends the two together. But here's the idea with interface inheritance. A function expecting a base type, that is a truck in our example, passed as a reference argument to say maybe a function. What we can see here is that, so here, let me set this up. So let's say we have a fire truck, FT. Say we have some sort of function, go to location, and let's say we have const truck T. If we call go, can't read my own handwriting, go to location on fire truck, what we're going to see here is a implicit conversion between the derived types and the base types exists. So in this case, we're not actually creating a new object. We're going to be shifting at how we're looking at that object because we're passing by reference here. The type is the base type. So if we take a reference of the base type to an object of the derived type, such as a fire truck, it's going to allow us to look at just the base type of our fire truck. What that means is whether it's a fire truck or a concrete truck passed to this go to location function, the functionality that we will have available within that function's definition is going to be the complete interface of the base class. So any of, these functionalities, this common functionality could be invoked on that reference argument T. And the reason is that fire truck and concrete truck inherit the interface of truck. So the things that a truck can do, such as forward, stop, maybe we define reverse, is something guaranteed that all of our derived types from truck are going to be guaranteed to support. So that's what's kind of meant by this interface inheritance, is that the derived types are inheriting the interface of the base class. So they're guaranteed, provided we're using public visibility of inheritance and setting up this idea that a fire truck is a truck, a concrete truck is a truck, it's going to be guaranteed that they can do everything that the base class can do. So if you just look at them as, say, a generic truck, it doesn't matter. They can all do the truck things. So within this function, they could do anything that a truck can do. So let me just read through this. So I modified this definition. It looks like it's turned into a bit of word jargon here. But so interface inheritance, a function expecting a base type, such as a truck, passed as a reference. That function can take a derived type. So in this case, go to location, and use a derived type through the interface provided by the base type, that is truck. And I think that's what we've hopefully effectively communicated here, but perhaps in a more, tangible way here, because that is a bit dense. But the idea here is implementation inheritance. You can do everything that you can inherit the things that the base type can do. And then you also have this ability to kind of go the other direction in that you have this interface, which all the derived types are guaranteed to support, provided a public mode of inheritance. So let's get into these modes of inheritance. Let's talk about the visibility of inheritance, and then we'll jump into a conceptual inheritance walkthrough, which will take a little bit of time, but I think it'll be productive. And finally, to really, I think, pull things together, the additional material by example will be a very productive video to watch carefully.